Before we move on to solving matrix equations that involve adding, subtracting, and scalar multiplication, I would like to talk about two special matrices that you may run across when you're adding or subtracting. So the first one is the zero matrix. So let's talk about the zero matrix. The zero matrix is a matrix where every element in the matrix is zero. So for instance, this is a 2 by 2 matrix where every element is 0. This is a 3 by 1 matrix where every element is 0. This is a 1 by 4 matrix where every element is 0. If you need to use the zero matrix, you can reference the zero matrix by referencing it with a 0, and then the dimension of the matrix that you want to have all zeros. So for instance, a 2 by 2 zero matrix would be a subscript 0 and then 2 by 2. A 3 by 1 matrix would look like this. And a 1 by 4 zero matrix would look like this. So these are shortcuts for writing the zero matrix. Why do I even care? Well, let's take a look at an example where we are adding, let's say we add a 1, 2, 3, 4, and we add to it the 2 by 2 zero matrix. When we add these two matrices together, just as an addition or subtraction, when you add or subtract a 0, your original value doesn't change. That is called your identity. This is the additive identity for matrices. The additive identity for matrices. And that's why it's important. Another matrix that you might run across, especially when we're solving equations, is the opposite matrix. So our nice little opposite matrix here. The opposite matrix. Given matrix A, the opposite matrix is one where every element is opposite to the element in matrix A. So what does that mean? So let's build a matrix, and we'll just call it matrix A. We'll fill it with the values 1, 2, 3, and 4. The opposite matrix to matrix A, and I'm just going to call this opposite matrix, matrix B, is where every element in matrix B is opposite to the element in matrix A. So it would be -1, -2, -3, and -4. And you can see every element is opposite to the one in matrix A. If let's just say this was a -2, the only difference, opposites are just the same number with different signs, we would have a +2 in the opposite matrix. So why do we care? Well, let's take a look at an example. If we are adding two matrices that are the opposite, say 7, -6, 4, and -1, if we add to it a matrix that is opposite, what happens to this matrix? Well, when we add 7 and -7, we get 0. -6 and 6, we get 0. 4 and -4, we get 0. -1 and 1, we get 0. We end up with the zero matrix as our result. We're going to add opposite matrices when we start solving matrix equations to help us solve those equations. And the last thing I wanted to talk about was the concept of equal matrices. So I'm going to go ahead and get rid of the definition of zero matrix and opposite matrix. And I want to take a look at equal matrices. two matrices are considered equal if every element in the same position, every element in the same position is equal. So for instance, I could write this matrix right here and I know that these two matrices are equal because I can represent some of these fractions and integers in other ways. I know these are equal because 0.25 is the same as 1 over 4. 1.5 is the same as 3 halves. -3 are the same. And then 4/5 is the same as writing the decimal 0.8. Well, I might not be so specific when I tell you two matrices are equal. I might actually ask you to solve for variables that would make my two matrices equal. So for instance, I might say, what are the values of x and y such that it makes these two matrices equal? And I might give you the matrices. Let's see, 9, 2y minus 1, 3x plus 1, and 10. And I might set that equal to 9, 16, -5, and 10. Well, it's clear that these are equal, and these are already equal. But what value of x would make 3x plus 1 equal to 16? You can set up an equation to figure that out, and you can solve it. Subtract 1 from both sides, and then divide by 3. X would have to be 5 in order for these two elements to be equal. And now we're going to do the same thing to find out what value of y we would need in order to make these two matrices equal. So we set up an equation, we add 1 to both sides, and then divide by 2, and we get y. It has to be -2 in order for these two matrices to be equal. So that's a concept I wanted to discuss before heading out and taking a look at matrix equations.